Before we begin, I'm going to introduce our speaker for today, Christine Marquis. Christine is a teacher at Cégep de Saint-Jérôme. She teaches chemistry. She also is a researcher at the college level, a college researcher. She's a member of GRIPTIC. It's a group for inter-establishment research on pedagogical integration of IT, technology, and communication. So she is a member of that group. It's a select group. She has done research activities and continues to do so that are funded and that inform the practices of teachers. She's also interested in practices and experimentation of new practices for innovation in science and mentoring activities for researchers. So have a wonderful webinar, everybody. Now, Christine. Thank you, Nicole. So I presume that I have to share my screen straight away. So hello everybody, thank you for being there today. I will present serious games, VR games that we developed for biology, chemistry, and physics, to talk also about the challenges, the benefits of these games with this VR technology. So these games come from a wider project where there were many parts, phases that were funded by the Nova Science program, the research funds, Fonds de Recherche du Québec, and the Canada-Quebec Agreement for Research Dernier Volet. So Nicole introduced me, so now I will introduce our first slide here to show you that I really did not do this by myself. This is the work of a wonderful team. As Nicole said, I'm a chemistry teacher, so I led this project with Bastien Wall-Lasselle, a physics teacher at Saint-Jérôme Cégep. We both worked on this together and acted as experts for content, me in chemistry and human physics, Benoit Lemieux, who was a biology expert for us, and the four people on the top right are the latest development, our development team. So the first three, they were students at university at the time, and they started a group for development of games, skill-based games, particularly for developing skills, game design, programming, and some of them had skills in modeling and animation, and an IT person who also other people who are very good at sound and music who worked with them together. So these games are produced because of our partners, Affordance Studio, who is specialized in designing educational games, serious games, Brainiac for VR and for scripts and stories, our partners at Université de Montréal, and also we had our teachers at Dawson College that participated in translating the games into English, but also putting together an accompanying guide to help utilize these games in class. So you can see here how excited they are in the picture participating in our project. So to break the ice, I would invite you to answer two short questions just to see who is with us today, find out a little bit about you. So I'm just going to make sure everything is up and running. Can you put the link up on the... Yes, I will leave up this slide here. Can you confirm that it works? I don't see the link. It's in blue, wooclap.com. Oh, yes, I see it. Okay. And the code is in blue as well. I think that there are some answers that must have came in. I don't see any. Okay, these are the results. So 37% of profs for science teachers, guidance counselors as well. So I am happy to see. Well, I think the games that were designed for biology, physics, and chemistry. But I think that in this project we've developed other things as well that could be used by interested parties, people who are interested in VR, virtual reality, can be teachers, can be guidance counselors, for developing more simple tools that can help you. So, the next question. Um, so, we have more than half of people that already have used VR in education, immersive VR. So, I think that we have some people who have experience, some experts with us here today. So thank you for that. I'm coming back to the slide deck now. What is the plan for today? Well, first of all, I'm going to talk about who these games are designed for. What were the objectives of the project? And I'm also going to talk about the follow-up process, the process we followed to develop our games. Because I see here we had people in nursing, for example. This process can be used to develop some tools in VR for nursing education. For example, it can be very relevant, very useful. So I'm going to introduce these games. Then I'm going to explain how we can use them in the classroom. And I will end with some research results that we did in parallel with the development. So who do the games serve? Who are they addressed to? So we developed a main game called Nova Science that is available. And when you start playing this game, in the beginning you can choose between three different games. First one is biology, around processes related to protein synthesis. So that's adapted to the new biology classes, the cellular biology course, but also can be used in other courses that touch on these concepts. For example, I have a teacher in biology at Hansa College who teaches a technical program. He uses this game in his teaching. In chemistry, it's more around concepts of molecule structure, molecular geometry, hybridization for general chemistry classes, and adapted to different programs that can be used in other courses that touch on chemistry. And for physics, these are concepts around energy conservation, circular movement, entropy. It was for mechanics specifically, but can be used in other physics classes, astrophysics, or other things that touch on physics. The objective is to talk about energy conservation and entropy. So the other game, this game has three parts, rather. So what are the objectives of the project? Well, the first objective is to develop VR applications that we want to be game-based, serious gaming and interactive gaming. So that was the first objective. Then, following that, we had a first version of these games. We wanted to translate them into English and take this opportunity to improve them. So it was another opportunity to field test them and to elaborate scenarios for pedagogical use and guides around the usage of these games so that they can be easily used in the classroom. And the last objective was the research part, was to evaluate the effects on the motivation, interest, engagement of students. So those were the three objectives. And this project connected with VR, as you probably know, because there's a lot of science teachers here, despite the importance of the teaching of science and have a basic science culture and basic knowledge, but the interest of students with regards to science seems to be reduced markedly as they advance in the school system. So when they get to primary school, they are interested in science, naturally, and as they progress through their education, interest wanes, goes down. So in post-secondary, it's more educational perseverance and obtaining diplomas and certifications that become important. So why is this drop in interest happening? There's many reasons. The concepts that we seek to teach are more abstract as we move forward, as the students move through the system and become more difficult for these students. So without necessarily a good context. Sometimes we teach them without the proper context. And so despite the fact that there are many initiatives in science, the methods for teaching are still developing, still have some work to do. So in this context, we think that virtual reality would not necessarily solve the problem on its own, but may be part of the solution to counteracting this loss of interest. And so to bring something special to the students and regain some of their interest. And it was in this context of availability of moderately priced, reasonably priced VR equipment. So a few years ago, you had to plug these pieces of equipment, these VR headsets, to very expensive computers, and it was quite prohibitive. But then we had autonomous VR headsets, so the computer is integrated into the headset, so you don't need a computer to run everything. So that made everything much more accessible, much more affordable than at the time. So at the time, there were cuts as well, so it was more difficult. Now it's much easier, also with the cuts we have today, to be able to use these and obtain them. So we have MetaQuest VR headsets. They were about $400 each. And I don't think you can buy them at that price anymore. The 2 and 3S. Now we are using the Quest 3. It's about $700 per unit. And the interest in VR, well, of course, the launching point was the availability of the equipment, the affordability of it. But we now see a lot of research being published around the impacts of VR. So the interest is increasing. We have meta-analysis that looks at the impact on engagement, learning, pedagogy in the classroom, the usage of VR. So virtual reality, what are the main characteristics? First of all, it is immersive. So that is related with the characteristics of the virtual environment. So this panoramic environment with the 360 view, etc. These characteristics that will allow the person in VR to forget that they're in their living room and to really think that they are in a virtual environment. So the presence element of it, this perception of being there in the moment, in this environment, this virtual environment. And the other characteristic is interactivity. It's this capacity to interact with the environment around us, the virtual environment, and obtain immediate answers to our interactions. And instead of just walk around and explore as it was in the beginning when we had virtual, when we were using VR for visits, for example. So now I'm going to present the process we followed for developing our games. So we were not really specialists at the outset. We had a lot of help, and we progressed thanks to our partners. And so we really started by building conceptual models. So the one that we followed is really inspired by the analysis of pedagogical value. So, three main steps. The first one is preconception, pre design. So, we looked at the literature to study the characteristics of VR, but also the developments, the innovations that came before us. And then the second thing is we did an analysis of the current needs. So, in doing a survey with the teachers participating in one of our projects, we were trying to see, we asked, what would be the classes, what would be the concepts that would be relevant to experiment with VR, to use in a VR context. So, functional analysis is the second part, analysis of comparables. So, what we've done is we've put together a diverse team. We had CEGEP teachers, college teachers, university teachers in different technologies and educational technology, and also didactics and guidance counselors as well. And we had one student at the from the college level, one of each gender in our team, and we had VR headsets for everybody. And it was the time of the pandemic, so we had to give delivery at home. So they tested different educational apps, VR apps, science-based ones, and the idea was to pull out the most positive aspects of the experience, and then to look at the less positive aspects, and then have a discussion around all of that, and to develop criteria for quality, to develop a way to describe the positive and negative experiences, to make these into criteria for quality, so to evaluate quality, to inspire our development, to inform our development, so that the games we develop follow these criteria for quality that we defined, thanks to the participation of all these members of the team, the students, teachers, guidance counselors. And then in this model, it was the third part, the prototyping and interactive testing and modification. So that's where we can modify the model. And seeing in blue here, these are the different steps that I've presented, the three different steps. But what we've done in our process is we've added, because it took a lot of space, a lot of room, the ideation, the whiteboarding. So the whiteboarding brainstorming sessions, we had to find what we were going to include in the games and how we were going to explore different themes and make it fun. And so it's not necessarily the specialty of all of us teachers to make everything fun all the time. So we had to do some collaborative design and whiteboarding, and we did that with our partners that helped guide our vision. And we had three macro scenarios, three main pillars around which we've made a choice for each discipline, and we have a graphic representation of that here with the different steps and the scripts that we've developed, and we've documented the process. We have published a scientific article around this last year. So that's the process we've followed. And now it's time to introduce our games. Just explaining, first of all, that the games, they are available for free in French and in English on the Meta platform. So you can use the QR code, and you can go directly on the Meta website, and you can use the search bar and write Nova Science. And so the games, as they were designed, they are team-based, 2 or 3 players per team. And the when you play them with 2 people, there's a person that wears the VR headset. So that's the first teammate. And the second teammate, they see the representation in 2 dimensions. So they can see what's happening in 2 dimensions, what the other person sees. And this second person has a document, has a guide. So they have information. They have a guide that the main player doesn't have. So there's a collaboration there. He's a co-pilot, if you will, and there's a communication between 2 people to be able to progress through the game. So there's a pilot and a co-pilot that has a guide. So this is the model that we see in all 3 games. In physics, well, there are 3 roles. So there's 3 people per team. So the concept behind these games in biology is a game where you have to escape. It's an escape room, and the player is miniature, and they have to cure a genetic disease and synthesizing the protein and injecting the correct gene. So you have to explore and build proteins, synthesize proteins. In chemistry, well, the concept of the game is you have to get aboard a time machine where you will be carried towards ecological catastrophes, where you will have to solve mysteries related to molecules involved in these ecological catastrophes. And in physics, the storyline is you have to launch a rocket to go to a space station to discover and understand the mystery of dark matter. So that is the description of each of the games. So I would have really liked to put my VR headset on and project the content live, to stream it live for you today. But I didn't have the time to build that out and for this presentation. But we have made some videos here with the camera that's built into the headsets, just to give you an idea of what the games look like. That's what I'm going to show you here. It gives you an idea of what you would see in the VR headset. So just explain also that the games are all built on the same model, that we are entering a prep space. So we first choose the game we want to play, the language. Then once that's done, you get into a prep area where you are given the context, where the game is framed, where there's the story of the game, the guide that helps you to start the game. So there's also a word association game where you have to take some magnetized words and associate them on a whiteboard, put them together. So the students get familiar with VR. It's just a way to get them used to it. They've probably never done it before. They don't know how to use the hand controls, and so that takes a few minutes to give them a bit of time to familiarize themselves and also to get in contact with the subject, to get an introduction. So the sorry, I'm going to interrupt you. The meta link you put up doesn't work. And there's somebody who's asking Melanie to talk about the role of the 2 players on the physics team. So I'm going to check the meta link. I maybe can put it up live for you. And the role of the 2 players in the physics team, other than the VR person, we have one VR person per 2 players. So there's one person that wears the VR headset, and they have the hand controls as well, so the joysticks, and there's some mysteries, some enigmas that you have to solve in the game, and the other person has a guide, a document that guides them through the game. So there's some information about the genetic code for the biology game. So the second player also sees the content on a tablet or a computer. So together, with what they see and the tasks they have to accomplish, they have to plan as a team, and you'll see that on the video. But you can see the difference between the both roles is one of them is wearing the VR headset, and carries out the actions, and the other person has the information on a guiding document, and that's the co-pilot that helps the other person to take the right actions in the game. So I'm just going to start the video and hoping that it works. Okay, so here you have the credits, opening credits. So you choose biology. So this is the prep space. So this gives you some context. We have some information on the wrist of the player, some information to guide them. So it's more to be familiar with the controls, really, to get used to the VR environment. So then you get into the cellular structure. There's information there. The player must go and choose the nucleotides and put them in the right sequence. So we take the RNA strand, messenger RNA. There's the splicing machine there. Then you go into the cytoplasm, where you have to now do the process of translation. And then we use transfer RNA, and then we use the the amino acids. You need the genetic code. It's the binome that has that information. So then our idea is to build a protein to cure our patient. That doesn't work. I made a mistake there. I'm correcting it there. And now I can build a protein. I will put it into this machine here and prepare the protein. It's not everything. You don't see everything in the video there. There's other parts as well, obviously, but I haven't put everything in the video. So I am going to show the chemistry game now. This is where you enter into the time machine, the teleportation time-based machine, to go and study these molecules that are responsible for ecological disasters. So it's the same kind of thing. You have a room to start, a guidance area to start the game, and you are in Beijing to start the game, where you have to answer some questions related to molecular geometry, different hybridation, and different molecules like ozone, sulfur dioxide, and then Beirut, where there was an explosion in Beirut with ammonium nitrate, and Bhopal with isocyanate, methyl isocyanate in Bhopal. So I'm going to show you that. So that's the ante-room, if you will. That's where you start the game. You have to take these objects and to get comfortable with the hand controls. And then that's the teleportation room with the time machine. And you get into the machine. It'll close. Then you start your time travel. You end up in Beijing. You choose the right Lewis structure. I'm doing this very quickly here. The partner has information between the different information that you need to progress through the game. The co-pilot helps with that, and there's models here. You take in your hand molecular models, you observe the environment and compare, and then you choose the right one, the most plausible model for nitrate and ammonia, and then the last time travel, the last jump. You are in Bhopal, India, and then the idea is to choose the different atoms, the type of hybridization, the atoms of the molecule, and once it's done, I saw students take the time to look at it, observe it, look at how it's made, and look at the geometry of the molecules. And the last one, the physics game, I'm just going to launch that. So you have to calculate the energy required to launch a rocket. So all about energy conservation, conservation of energy, and really related with astronomy as well, the different speeds to discover, to explore the mystery of dark matter. So, I don't know, Nicole, if you have any other questions or any comments, or there's Laurie who's wondering how much time the game lasts, how long it takes, the biology one. That's a good question. In the sense that, as I was explaining, the game, we have periods of about the game in and of itself about 25 minutes per play. So it takes some time to prep the material, to get these students into the game. So what we like about these games is that they are integrated into classroom scenarios, or into cursus, really. So we can, in for example, a lab that lasts 2 periods, that the activity can take place over 2 classroom periods, or 30 minutes per activity. So if you're interested, well, the videos were produced a little while ago now, so they've been improved and upgraded since then. But if you're interested and convinced, and you're wondering how you can use this in your classroom next week, for example, well, the good news is, before, the way you would do this is that you would write me and I had to guide you, explain, have a meeting with you, guidance counselors, IT people. There is some prep work to be done. But with the last phase of the project, what we've done is we've developed a quick start guide, a document that we've put on a website. So documents, guides that are really destined for students. When I said that the second person, the co-pilot on the team, has a guide, a guiding document, it's available on this website. Also, for the students, we have a familiarization guide with the equipment to get them familiar with the VR headset and the hand controls. Many of them have never used VR before, so just to explain a little bit about how all of that works. And then what we're really happy to have been able to do as well for the students is the teacher's guide. So we're going to show you what it looks like. I'm just going to go to the website. So you have the website here. This is where you can choose your language. You can have it in French or English. The games and documents are in both languages. And you have the link here that you can use to connect to the games. There they are, right here on Meta. So you can download them. If I go back to the website here, you have all 3 games, biology, chemistry, and physics. And with these tabs here, you have access to all the documents. So what's really interesting for teachers that want to use these is to read the guide, the teaching guide. And truth be told, it can be a bit of a learning curve to integrate these games for the first time. But there are alternatives. We can also propose activities with smaller groups of teachers to test them out and really get familiar with everything. So the guide for the teacher's guide is there. It's a PDF document that gives you all the information related to the games. So you have a description here. You have this is the biology one, but it's pretty much the same for physics and chemistry as well. There's the description of the game, and I have all the information around the materials, a technical guide, technical specs, what kind of equipment you need if you have a MetaQuest 2 or 3. So, you need a tablet or a computer for each team. A computer generally works better. We also have a list of the documents needed and what each of them contains. And for the logistical elements and technical elements, we have an annex to an addendum with all the different technological aspects and details that you need. Also, the pedagogical planning, the cursus, and what I would like to do here is to test the game if you want to test it. But if sometimes you don't really understand it all and you're blind, it goes through it step by step. It's like an FAQ guide, if you will, that it takes you step by step through the game, all the different actions one by one in detail. And then I will get to the appendix here, Appendix 2. As you see up on the screen here, there are a lot of CEGEPs and colleges have this equipment. Others no, but how many VR headsets you need, the meta accounts you need to create, how to do that, how you install the game, Wi-Fi. You need Wi-Fi to mirror the content of the headset onto a computer. So there's all kinds of security parameters that you have to go through. So that's something you have to think about and set up ahead of time. There's all the details here in this guide, all the things you need to think about and set up and plan for. For example, you need a special space adapted to using VR. We have developed all of this and this toolbox for you. I am currently working on knowledge transfer for this project. So if you have an interest in this or any questions, you have my email. You will have it at the end of the presentation, and it will be shared with you with this slide deck. So you can contact me if you have any questions. I will be very happy to discuss with you. So we've also organized some meetings with different members of the staff of different colleges who had questions on how all of this works. So we have that kind of meeting as well. So I don't know, Nicole, if you have any questions before I start the last part of my presentation. I have no questions for now, but I'm interested in the opinion of the students on how they see all this and if they're interested in participating. So very good. So all throughout the development of this, it was planned that we would do a study, an exploratory study on these games to understand the point of view of the students, but also the teachers with regards to using these games. So the methodology is research-oriented, design-based research. So the idea is we've developed these games, but through our research and for different reasons, we wanted the teachers to put together a pedagogical scenario, a screenplay, if you will, so we've collected data with the students, with group interviews and surveys, with teachers and students, and we've collected the data, done a data analysis, and then that informs the second iteration of the pedagogy. So there's a first iteration in the Francophone environment, students, 88, 6 teachers, 88 students, and then Anglophone, 200 students, 26 teachers. So this is to show you that our intention is that the games are integrated in pedagogical scenarios. In the research scenario here, the research plan, we've helped the participants by guiding them and showing them how to put together their screenplay, their scenario. We put together a canvas, a framework for them to use, similar to the one they use in nursing sciences and nursing for their simulations. So what they do in their labs, they have a game and there's a setup for the game. There's a briefing that really resembles LIAS with all the instructions. And then there's the game that we really call a simulation more than a game. But there's the most important part is the debriefing at the end. So that's the idea, the results now. So we've used this survey to get the impressions of the students, to get their appreciation and experience. So we had 297 answers and 297 participants in group interviews. And what we've observed is that the positive effects come out mainly on the emotional level and then in learning, in the educational part of it. So those are the main aspects. And the themes that really come out a lot for 25% of the students is appreciation. They've really enjoyed it. And then the fun that they had, that really came out strong at 23%. They were excited. And we see also in the open-ended questions, the theme was to learn by having fun. So that's something that about 11% of the students said. And what we noticed as well in the open-ended questions are the 5 themes that really came out strong, that the most people mentioned. 2 of these 5 concern the visualization and increased comprehension. So yes, I had a lot of fun. Yes, I appreciated it. It was good and I enjoyed it. But also a lot of people said it helped me to understand more complex concepts that I found difficult. It helped me to better visualize molecules and better understand, increase my comprehension. So we see the effects in the impressions at the emotional level and educational level as well. So the questionnaires had different scales of motivation and of interest, situational interest. So the interest generated by the situation, by the activity, and the level of engagement. So we wanted to see, first of all, if there were differences between the 2 iterations. What we tried to improve in the games, the results show that there's no difference between the iterations except for improved efficiency and not necessarily related to the games. But in red, what we can see here in the data, what's interesting is the highest scores really are around the emotional aspect. So to what level I found this activity pleasant, agreeable, enjoyable, there was a whole series of adjectives. So that's the part of the higher scores, the situational interest as well. So the interest that is engendered by the activity, brought on by the activity, and the emotional engagement. You can have behavioral engagement, you can have observational engagement, but it's really to condition the students to get with positive emotions like enjoyment versus more negative emotions. So that also came out with higher numbers. So for the teachers now, we had in the both iterations, 15 teachers that participated, and the themes that were the most covered are motivation of students. So they've observed that during these activities, the students were very motivated. They found that it allowed the teachers rather to have a different method of teaching, but the impact on education, on learning, what it translates into as the teachers, what they were saying is where they really observed the motivation of the students much more than usual, etc. And also for the learning aspect of it, they couldn't say immediately if there were negative or positive effects or no effects. They couldn't judge that on the immediate. And so the different themes was also some technical aspects and the enjoyment of the game-based aspect of it. So we asked the students around the challenges that they experienced. So what are the challenges that you've encountered? 7.7% talked about bugs. The learning curve. They had difficulty progressing at the beginning in the game. And in the interviews, what came out a lot, a specific question talked about cyber sickness, cyber illness. So a kind of nausea that comes with VR. So there's an iteration where one of the teachers, there was time in the class left, and she encouraged the students to go and explore the other games in chemistry and physics. And so the students spent too much time in the VR, which really caused some discomfort, some physical discomfort. So you have to remember to limit exposure. If you have to switch the teammates so that nobody is exposed for too long, because it can create discomfort. So for the teachers, the main challenges were technical and situating the students to start the game, and time for planning as well. So following all of this and their experience in integrating these games into their classroom, we asked them, in your opinion, what is the advice you would give? What would you say to people to guide them to implement VR? So what they said was to provide a guide, a series of guiding documents, which we've done. So to be accompanied also during the activity. So that's something as well, to have a person to guide or assist them. So this is not an easy task, especially in the beginning. The whole technical aspect, the learning curve can be steep. So it's good to have a mentor, another person. Sometimes in the labs, there were other teachers that came in and helped. And so for guidance counselors as well, there's some technicians that could come in and help with that. We even hired some students to assist that really helped. So to just think about accompaniment and finding an adequate space to use VR, to be able to plan for surprises, to be able to have a backup plan. And so in conclusion, the positive aspects and the advantages we see in VR, well, first, it's really on the emotional level. And for us, it's something we can't take for granted. In the context of the drop in interest in sciences, is to really come in and give them an exciting experience, something that is relevant at the pedagogical level, but also something fun, exciting, that we think is something that can be very valuable. And also, there are some advantages in increasing comprehension and visualization. And for teachers, this is an opportunity to use different teaching methods. So for challenges, there's cyber nausea, cyber discomfort, and the prep time also. Taking the time to prepare correctly, testing the equipment, and looked at all the different elements, and to prep correctly, that will really reduce the technical issues. And also the need to be accompanied, to find a mentor or somebody who will help us through everything. So a few questions. Yes, well, I'm finished now, so you can ask questions if you need more information. We will be in the next edition of Pedagogical Collegial magazine. So this is my contact information up on the screen here. I don't know if you want me to stop sharing my screen. Yes, you can do that. Anyway, people will receive a copy of the slide deck. So my contact information will be there in the email and in the slide deck. So Caroline Paralardi is asking if you had any problems of mirroring the VR headsets, if you have many of them at the same time. We've had that problem when we were using the iPads in our first run. In the second run, using computers worked much better. But again, you have to plan for that eventuality and test for that with IT. So you have to have a place that won't be too far from the Wi-Fi, where the Wi-Fi signal is strong enough. That really helps as well. So yes, there's a possible source of technical issues there. But you can plan for that and test it out with IT. Usually if there's good Wi-Fi, if you're close to the Wi-Fi, it works well. Thank you. There's another person here who's asking, this type of game, this type of VR game, can it be used in language learning? Have we thought of that? Do you know if we've started to look at that? If anybody has started to work on that? I think so. I think yes. I've seen that in my research. We have to check. But yes, I'm pretty sure. And it would be easy to find anyway. So I think for me, VR is I'm really concentrated on my games and everything. But we see that there are some VR meeting rooms, VR conversation rooms, Mondo VR, for example, where the idea is to practice different languages in a VR environment. So that's one, but it would be easy to find. There's a few of them out there. Maria, who is asking the question, what would be the optimal length of an activity, a VR activity? Well, as I said, the objective is to avoid discomfort, is not to go over 25 minutes. But to maximize the benefits, the educational benefits, we want to integrate that into a class debriefing and briefing at the beginning and group interview and everything. So you can say that 2 teaching periods, a lab, for example, or 3, if 3 units if you want a longer activity, but in 2 periods you can do all of that, the briefing, debriefing, and gaming and everything. Marianne also asked the QR code to the scientific article. I don't know if you talked about a scientific article. Yes, I have a QR code. Maybe it's because of the screen share in Teams that the resolution wasn't that great and people couldn't scan it. But that's easy enough to find. I can put up the links in the chat, and you can include them in the email that will follow the presentation. Thank you very much, Christine. If there are people who have any other questions, they can contact you. I think people really enjoyed the presentation today, and I hope we will see you soon and read your articles. Thank you, Nicole. And I will remind all of you that if you have any questions or comments, please don't hesitate to contact me. And after many years of work in developing these games, of course, our great pleasure, our great fun is to discuss, to share them with others when I see students, teachers that enjoy them, that use them. So if you have any questions, please don't hesitate.